guys, today what we're going to work on is using our properties that we've been working on to solve log equations. What I did for this topic is this is a worksheet I made on Kudo software for Algebra 2 a couple years back. It's a nice easy worksheet to kind of teach you the basics off of. I did put a PDF version of this worksheet up on Google Classroom today. So if you want to pause me and print this out so you have your own, you don't have to do that, or you could just write down the problems I'm going to do on a piece of paper and take some notes on it, but you have options. So big thing I want to talk about here with log equations is there's two different basic types. Ones where you have logs on each side of the equal sign, like you do here in the first one. See, there's a log there and a log there. And equations where you only see one log functions, like number 6. You handle them very differently. The easier ones are the ones with logs on both sides. The ones with one log only require you to rewrite the question. So I want to kind of show you what that means. So let's go back to the first one. Notice they both have log base 10, even though the 10 isn't written there, it's the common log. Both of them have log base 10 on each side. That means these pieces are equal to each other. So that means in order for the equation to equal each other, the numbers n plus 9 and 4n would have to equal each other. So all you'd have to work with is do n plus 9 equals 4n, and then solve that. 9 would equal 3n, so 3 equals n. Now before I circle it, this is very important. These you do have to check. The locations I just underlined can never be 0 or negative. So when I plug in 3, I get 12. If I plug in 3 there, I get 12. I'm okay. So now that's the solution to the question. So now let's jump here, and so I can show you the other version where there's only one log in it. Now, over in the first one, basically how you want to think about it is the logs cancel out, and you just work with the leftover pieces. Here, we actually have to rewrite this using Ben. Now, first thing we can do, see the 7 out in front? You have two options. You can either write that as his exponent, or, which I think is easier, just divide both sides by 7. So the 7's cancel, and we end up with log base 9 x plus 8 equals 1. So once you get into this format, then we do Ben, base exponent number. So that becomes 9 to the first power equals x plus 8. 9 to the first power is just 9, so when you subtract over the 8, you get 1. And again, we're going to check. Go back to the original question. If I plug in 1 in here, it doesn't make a 0 or a negative, so I can circle it. So that's basically what we're going to be doing. They're going to get a little more difficult. This is a pretty straightforward worksheet. I'm going to do come on the more trickier ones next time. But let's look at number 7. When I look at this, I notice there's only one log function, so I know eventually I'm going to have to rewrite it like number 6. But the first thing I want to handle is this negative 8 out in front that's being added to the log functions. I'm going to add that 8 over to the other side. And now I have log base 9 m plus 1 equals 0. Now I'm going to do Ben. Base exponent equals the number. All right, now what is anything to the 0 power? Bring it up here. It's 1 equals m plus 1. Subtract the 1 over. I'm getting m equals 0. Now, that is okay, as long as when you go back to the original, you don't have a 0 or a negative here. So if I plug 0 in, it makes a 1, so that is fine. So I'm going to circle it. All right. Let's take a look at number 11 now. Number 11 is just like number 1, where I see two log functions. And notice these are both log base 19. That means I only have to work with those parts. So we got x squared plus 17 equals 8x plus 2. Now it's a quadratic, so I'm going to set it equal to 0. Subtract over 8x, subtract over the 2 over 15, right? That's going to factor x minus 5, x minus 3. So I have two potential answers, x equals 5 and x equals 3. Now again, I'm not circling anything until I go back and check. If I plug these numbers into these locations, I cannot have a 0 or a negative. And it's not going to happen on this one. So this question actually has two solutions. All right, now I'm going to do is flip this sucker over. And we're going to do a few on the back to bring in some different operations. So let me take a look here at number 13. Now, notice we have subtraction going on in here. So you cannot do any work on these until you get to, like we had on the front, either a log on each side or a singleton log. And over here, notice we have log x minus log 6. Well, in the land of the logs, what is subtraction the same as? We think in division. So this becomes log x divided by 6 equals log of 15. All right, now once we get down to one log on each side, we notice they're both log 10. We only have to work with these guys. X over 6 equals, I'm going to make 15 over 1, cross multiply. I do believe that is 90. Right, 15 times 6. So, next thing I'm going to do is check. Again, I'm going to use a different color. Here, here, and here can never be 0 or negative, which won't happen. So the answer to that question is 90. All right, let's take a look at 15. Right? In the land of the logs, subtraction is division, and addition is multiplication. So this very simply is just log x times 2, which makes 2x. And I know these are simple. We're just reviewing, going over some basic things. These will get more interesting, trust me. Notice there's a log on each side. 2x equals 2, x equals 1. A quick peek won't make it 0 or negative, so I circle it. All right, take a minute now. Take a look at 16 and 17, right? Pause me, try 16 and 17, and turn me back on. Okay, I hope you gave me a pause. Hopefully these were nice and quick and easy for you. This was log 8x equals 1. Now, I'm hoping you realize there was only one log in this. So that means we have to use Ben to rewrite it. And the first thing I'm thinking is, what is my base here? Well, my base is 10. So I'm going to rewrite this as 10 to the first power equals 8x, right? Got to get x alone, divide by 8. So 10 over 8 equals x, which is 5 over 4. And that's the best answer, 5 over 4. Always reduce your fractions. Okay, let's take a look at 17. All right, this is also multiplication. So this is going to be log base 4. You're going to multiply these together. So I'm going to get 10x squared minus 30 equals 1. One log function, so that means I'm going to use Ben. 4 to the first power is 10x squared minus 30. All right, now I'm going to solve this. It is a quadratic. Instead of setting it equal to 0, since it's only an x squared, I'm actually going to add the 30 over. So I get 34 equals 10x squared. I'm going to divide by 10. So I get 34 over 10 equals x squared. This can reduce. This will be 17 over 5 equals x squared. Now I'm solving here. So when I take the square root of this, right? Remember, since we're solving, actually I want to make that in red. I get x equals, oh, my phone is going off. Okay. And when you take the square root of something, it's going to be plus minus 17 over 5. Now we do have to check, right? Come over here. If I plug in a negative radical 17 over 5, would it be okay? The answer is yes, because it's being squared. So this is two answers, plus minus radical 17 over 5. Okay, number 20. take a minute, do like last time, pause me, and see if you can do number 20. Okay, so I hope you paused me. I'm hoping you realize this was a division question. So log base 3, x squared plus 8 over 4 equals 3. All right, again, one log only, so I'm going to do Ben. 3 cubed equals x squared plus 8 over 4. So I'm going to bring it up here. So it's 27 equals x squared plus 8 over 4. So I'm going to put that over 1 and cross multiply. That looks like it's 108 equals x squared plus 8, right? Yes, 108. Subtract the 8 over. Again, when I take the square root, it's going to be plus minus 10 equals x. And I'm not going to circle it yet. I want to check. If I square the negative, it will become a positive, so I'm okay. You do have to reject sometimes. I know I didn't have any going on in this question page, but we'll have others. Now, let's talk about these last doozies down here, 21 through 24. Let's try 21. Now, the first thing you're going to notice is it's natural log, so that means our base is going to be e. But the same rules apply. Adding means multiplication. So this is going to be the natural log of x plus 7, x plus 3 equals the natural log of 77. Now, there's a natural log on each side, which means we can drop it basically and just work with this stuff. So I'm just focusing on this and this. I'm going to distribute here. So it's x squared plus 10x plus 21 equals 77. I'm going to set equals 0. Minus is 77. I believe I'm getting, I don't know what that is because I'm awful at subtracting. 21 minus 77, negative 50. So I get negative 56. All right, now we're going to factor this guy. And that factors into x plus 14, x minus 4. So I get x equals negative 14, x equals 4. Okay, now let's take a look at my answers. Negative 14, if I plug that in there, I get a negative. So I'm going to reject him. So there's only one answer to this question, and that question is 4. So this is the first time you've seen something be rejected. All right, now, 22. 22 is kind of special. So what I'm going to do is actually do 22 where there's more space so you guys can follow along. So 22, I'm going to rewrite it. This is the natural log. X plus 1 minus the natural log. So minus 1 equals 3. All right. Natural log and subtraction. So it's definitely a division question. Natural log of x plus 1 x minus 1 equals 3. See, only one log function has to be the natural log function, so I'm going to use Ben. And natural log means my base is e, so it's e to the third equals x plus 1 over x minus 1. Okay, this is a fraction, so I'm going to make that look like a fraction, cross multiply. So e to the third times both of those makes e to the third x minus e to the third equals x plus 1. Now it's important to keep in track of what you're solving for. Keep track of what you're solving for. We're trying to solve for x. That means we need to get everything with an x on one side, everything without an x or a constant on the other side. So what I'm going to do here is subtract x over. And then add e to the third over. So e to the third x minus x equals 1 plus e to the third. Now I'm trying to solve for x. What do both of these have? They both have an x, so I'm going to factor it out. Now to get x alone, I divide by e to the third minus 1. So the answer to this question is x equals 1 plus e to the third all over e to the third minus 1. And that is the answer to the question. So what I would like you guys to do now, take a look at these last two questions here. What I'd like you to do is pause me and see if you can get those. So you should be pausing me. Give those a try. Okay, so I'm going to run through these now. And let's see if you got them. So like last time, it's going to be a division question. So it's going to be the natural log of x plus 2 over x minus 1 equals 1. So this becomes e to the first. I'm not going to write the 1. So e to the first equals x plus 2 over x minus 1. I'm going to cross multiply. So we get ex minus e equals x plus 2. Right? Going to flip-flop those two. Going to get the x over here, the e over there. So that becomes ex minus x equals 2 plus e. Factor out the x. And then divide by this guy. So the answer to 23 is 2 plus e over e minus 1. Right? Now, let's say you moved it around differently. I'm going to put or here. You could have also ended up with something like negative 2 minus e over 1 minus e. This is what you would have had if you moved it in different directions. So both of these are acceptable answers. Draw a line here. Okay. 24. Let's take a look at this. Again, division. Right? You're going to bend it. Okay? So over 1, cross multiply, e to the 5th x plus 2e to the 5th x plus. Right? Factor out your x. And we've done other things like this year, especially like when we did inverse functions. So now this becomes x equals 3 minus 2e to the 5th over e to the 5th minus 1. So that's the answer. Or if you spun it around the other way, I believe it's negative 3 plus 2e to the 5th all over 1 minus e to the 5th. So both of these mean the same thing. Okay? And that's what I have for you. So I have a few ones like this set up for you to practice for homework tonight. And tomorrow we're going to practice some other versions of these. All right. See you guys soon. Enjoy.